and welcome back to our last week of remote learning. So this morning in maths we're going to do our last lesson on word problems. We're going to do our chapter review tomorrow and then we're moving on to something completely new. First of all, let's warm up our maths brains. Can we find the number 65? The number 65. Where's the number 65? It's going to be in the fives column, isn't it? Because it's got 5 ones and 6 tens. It's here, the number 65. Now, go
the other way.
No,
No, go left. It's left. Oh, there you go.
Oh, I was thinking, it's not there. I put it in the wrong order. No, it is there. It is just in the wrong order. Right, number 65. What I'd like you to do, you can do this with your eyes closed because you are that good. Partition it into tens and ones. Off you go. Oh, this is too easy, isn't it? That's right, 60 and 5. Right, what happens if we're going to partition it into 3 parts? You could partition your 5, and we looked at that fact on Friday, didn't we? 2, 3 and 5. 2 and 3 makes 5. 5 take away 3 is 2. 5 take away 2 is 3. We know those facts, so you could partition the 5. You could use the facts you know about 6 to help you with 60. We know that double 3 is 6, so you might use 30 and 30 to make 60. Great. So I'm going to use 10 and 50 and 5 because I know I've used this knowledge. 1 and 5 makes 6, so 10 and 50 makes 60. Now we can't see this number as 60 because the 0 is hiding behind the 5. Right, let's skip forwards now. Okay, now today's word problems are all about thinking about the difference between things. We've done lots of finding the difference. So the first question is to think about how far apart are the 2 teddy bears? What might we need to do to work that out, to find out how far apart are the teddy bears? That's right, you'll notice that underneath them is like a track, isn't there, with footsteps on there. So we can actually, a bit like non-standard units of measure, couldn't we? We could use the footprints in the squares to see how far apart they are. We could count them. We could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They're 15 squares apart from each other. What do you think the red flag is in the middle? What might we be able to say if, instead of saying the teddy bears are 15 squares apart, what else might we be able to say? Brilliant. We might be able to say that this teddy bear is 1, 2, 3, 4, 5, 6 squares away from the red flag. So between the teddy bear and the red flag, that part represents 6 steps or 6 squares. What number sentence might we be able to give about this teddy bear from this flag? Perfect. We know that this teddy bear is 9 squares away. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know that between this teddy bear and this teddy bear, so that's the whole way, from here all the way to here, was 15 squares. Okay, 15 squares. I wonder if that's what these questions say. Oh, look, can do that. How far apart are the teddy bears? What's the distance in between them? We've looked at 2 parts. We said that 6 and 9. We've looked at the whole distance between them, which is 15 squares. Okay. Now, we've already worked out, haven't we, that this teddy bear here is 6 squares away from the red flag. And we've already worked out that this teddy bear here is 9 squares away from the red flag. And we also counted how many flags there were altogether. Now, this was really interesting. This is really interesting here because we don't know this number fact off by heart, 6 and 9, do we? We don't know, 6 and 9 is 15. We had to count in order to work it out. Now what we're showing here is by using this partitioning method, why might we decide to partition 6 into 5 and 1? Why might this be helpful? That's right, because this is a number bond. 9 and 1 makes 10. And if we've got 10 and 5, we don't even need to count that on anymore, do we? Because we are so clever. Let me see if I can very quickly find in here 10 and a 5. We don't even need to count on anymore. We are that good. Oh, that's 30. Here we go. We know that when we add 10 and 5 together, because we've counted it so many times, we know that when we start with no ones in a whole tens number and we put 5 or 6 or 7, you're going to put it in front of the 0, so it's going to make the number 15. 15. Perfect. So the distance between the teddy bears is 15. Okay. Let's have a look at the Lego bricks. Okay, now we've got, how many parts can you see in that picture? From the start flag to the red flag and then the blue flag. How many parts can we say? How many parts could we partition that whole number into? We could partition it into 1 part to there. Then we could partition it into 2 parts to there. And that little part at the end. We could have 3 parts for that whole number, couldn't we? So this part from the blue flag is 13 squares from the start flag. Shall we see? Sorry about the noise in the background. 1, 2, 3, 4, 5. So from the start to the red flag is 5 squares. From the red flag to the blue flag, 1, 2, 3, 4, 5, 6, 7, 8 Lego bricks. Year 2, please be quiet because Mrs. Cutler's trying to film. Thank you. And from the blue flag, after the blue flag to the end, we've got just 1 Lego brick. Now, we don't know these number facts, do we? We don't know what 5 and 8 is automatically. We don't know how to do that. We know what 5 and 1 is because we know the strategy 1 more. So we could put this part and this part together to make 6. Then we've got 6 bricks and 8. We don't know that fact either, do we? No. I wonder if maybe we could partition this to help us. What might we partition our 8 into to help us use our strategy of a number bond to 10? That's a good idea. We could partition it into 4 and 4 because 6 and 4 makes 10. So we've got 10 here and we've got 4 ones. If I slide my 10 and my 4 together, let me see if I can do that. You guys are going to be shouting at me faster than I can do it. If I've got 10, my whole 10, which is made up of 6 and 4, and the 4 extra ones, I will have the number 14. Well done. 10, 11, 12, 13, 14. Perfect. So we know that from here, all the way to, hold on a minute. It says it's 13 squares. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And 1. Oh, hold on. It's just to the blue flag.
Oh, we didn't read the question properly, Mrs. Cutler.
Goodness me. Look, it needs to be 1 less than the whole way. So we know the whole number is the number 14. But look, from the blue flag to the yellow or the orange start flag is 1 less than the whole number, which is why it's 13. Now, we already counted, didn't we? We know from the red flag to the start flag, there's 5 bricks. We counted those, didn't we? And we already counted the distance between the red flag and the blue flag. Look, we said there was 8 Lego bricks. Oh, the distance between the red flag and the blue flag is 8 Lego bricks. Right, okay, let's have a look at one more. We've got a toadstool at the beginning. Then it looks a little bit past halfway is a tree. And then we've got a post box. Okay, now let's try not to count them to work out how many there are, because that would be the most convenient way of finding out. Let's see if we can use our parts knowledge to help us. So let's look, how many parts can we see? I can see one part here from the toadstool to the tree. I can see one part here from the tree to the post box. And I can see a third part here from the post box to the end. So, well, this one, we don't even need to count that because we recognise that number straight away without counting. What number is that? That's a 4, isn't it? We don't need to count that. We recognise the number 4. We see 4 so often, things like on number dice, when we see them on the carpet. We don't actually need to count those anymore. We don't need to count those either. We can recognise how many there are there. That's right, there's 3. Do we recognise this number? No. We know it's going to be more than 5, don't we? But we don't know. I would say it's going to be less than 10. Let's count to check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I was right. It's 1 less than 10. Okay. So what we're going to do is, shall we find out how far it is from the toadstool all the way to the very end? What's our whole number? Our whole number is this number sentence. It's this part, 9, and it's this part, 3, and it's this part, 4. Can we spot any number bonds there that might help us? No. 9 and 1. No, there's not any 9 and 1. There's not a 7 and 3. There's not a 6 and 4. There's no number bonds here that are going to help us. So maybe we need to try and make some number bonds. Oh, this is a near double. Look, if it was 3 and 3, it'd be 6. If it was 4 and 4, it would be 8. So it's between those numbers. It's 1 more than 3 and 3, and it's 1 less than double 4. What's double 3? Double 3 is 6. It's 1 more than 6. What's double 4? Double 4 is 8, but look, it's 1 less than 8. So what's 1 more than 6, but 1 less than 8? That's right. This part here is 7. 3 and 4 more make 7. Now, some of you will be tempted to count that on your fingers, but we are really trying to work on recognising and learning number facts. And when we see this number fact, we shouldn't need to count on our fingers because we should automatically see, oh, look, it's a near double. It's not a double, we know our doubles, but it's a near double. So we'll use that strategy to help us know that 3 and 4 make 7. So now I can replace 3 and 4, and I've just got 2 numbers in my number sentence. Instead of 9 and 3 and 4, I've now got 9 and 7. So I've put these 2 parts together. So I know these 2 parts here. Should I put that in a different colour? Maybe not yellow, because you won't be able to see that on the whiteboard. These 2 parts here, 3 and 4, means there's 7. 1, 2, 3, 4, 5, 6, 7. Look, it's 1 more than double 3, but it's 1 less than double 4. There's not 4 there, is there, on each side? Okay, 9 and 7. Okay. Now, do we know that number fact off by heart? No. Do you know that number fact off by heart, Mrs. Marshman?
No.
No. So we're going to use a strategy to help us. What strategy might we be able to use? Should we try and use our number bonds to 10? In fact, what I'm going to do is I'm going to rub it out and I'm going to write it again because I'm running out of space and I can't really show you how I'm going to use my number bonds here. So let me do that again. So we've got 9, which represents this part. And we've put these 2 parts together. We've used our near double strategy to work out that those 2 parts make 7, 9 and 7. Now, I'm going to partition the number 9. We did this quite a few weeks ago, a long time before Christmas. Do you remember that, Mrs. Marshman?
I remember it well, Mrs. Gatland.
Me too, funny that. So, what might I need to partition my 9 into? 7 and what will make a 10? 7 and 3, you're right. So if I've partitioned my 9, so I've put these 3 here, over here, So now I have made a magic number 10 because 7 and 3 makes 10. Okay, so if I've partitioned 3 of my 9 over here, what will I have left? Oh, I know this number fact off by heart. It's 6. 6 and 3 make 9. Look, 1,
Sure,
2,
Mrs.
3,
Cutler?
4, 5, 6. I'm absolutely positive. Oh dear. So you might be giggling along with me if Mrs. Marshman does put my ridiculous video on tapestry.
I'm going to
Okay,
do it.
so we know now that we've got 10 and we've got 6. Okay, so we've got 10 and 6 more. I could count on from 10. I could go 10, 11, 12, but that would take a long time. I'm going to put 10 and 6 together. What might my number be? I wonder if I slide my 6 ones together with my number 10. That's right, I'll have 10, 11, 12, 13, 14, 15, 16. So in total, we've got 16 footsteps from the toadstool all the way to the end. So what's the distance between the tree and the post box?
I can't see it anymore.
You might need to have a look in your textbook for this. Shall I rub off all of my jottings over here so that you can see them? There's the tree and there's the post box. So from the tree to the post box, that's the part we didn't need to count because we recognised that automatically. It's easy peasy. The distance between the tree and the post box is 3 footprints. We recognise that. So how far did the rabbit walk in total? We've already worked out how far he worked in total by looking at this part and this part and this part, putting them all together in those steps, and we worked out there were 16 steps all together. Right, I'd like you to be really clever today. I'd like you to have a go in your workbooks at seeing how far. Think about the parts. 1 part, 2 parts, 3 parts, 4 parts, 5 parts. Oh my goodness me. Some of those parts you will recognise without even having to count. Okay? This is going to be really easy because look, if you look at the number in parts, you can recognise these parts without even having to count them. Some of you might even recognise that one. Okay? Now, before you go and have a start on that, I'd like you to have a quick look at this. This is a really, really tricky mind workout. Now, he says, I have got 4 more books than Ravi. How many books must I give to Ravi so that we have the same number? So if I put that into terms of Mrs. Cutler and Mrs. Marshman, Mrs. Cutler says, here's Mrs. Cutler. Here I am. Big smiley face. I've got 4 more books than Mrs. Marshman. Here's Mrs. Marshman. I've got 4 more books. So here's my stack of books here. Here's Mrs. Marshman's stack of books here. And here's my 1, 2, 3, 4. Okay, so these are all Mrs. Marshman's books. These are all Mrs. Cutler's books. And these are Mrs. Cutler's 4 more books than Mrs. Marshman. Look, she hasn't got an extra 4 here, has she? She's got none. She's got these, and then these are my 4 more. I don't know how many's in that pile. It doesn't really matter how many's in the pile. What matters is we've got the same amount. And the difference is I've got 4 more. So how many books must I give to Mrs. Marshman so that we've got the same number? Which books do I need to give to Mrs. Marshman so we've got both exactly the same? Well done. Some of you have spotted that 4 is a double. It's double 2, isn't it? 2 and 2 is 4. So half of 4 is 2. These 2 here need to go to Mrs. Marshman. And these 2 here need to stay with Mrs. Cutler so that we have got the same number. If I had number 20 books here, Mrs. Marshman would have the same. How many would we now have? 20 and 2 makes, well done, 22. Right, okay, good luck with your word problem solving, and we look forward to seeing all of your work on tapestry.